Olá, pessoal, obrigado pela presença de todos. Meu nome é Renato Cordeiro, eu sou um dos fundadores do Code Lab e um dos ministrantes da disciplina MAC 0475, Laboratório de Sistemas Computacionais Complexos, do IMES USP. Eu estou aqui acompanhado dos meus colegas e também ministrantes do curso, João Daniel e Tatiane Rosa, além do nosso orientador, o professor Alfredo Goldman. Hoje nós temos o grande prazer de receber para a nossa sessão de palestras especiais sobre microserviços, Jonas Bonér. Se vocês quiserem submeter perguntas para o Jonas, por favor, enviem no link disponível aqui no chat do YouTube. As perguntas podem ser em português e a gente vai traduzir elas para vocês, né? Só para concluir, né, eu vou repetir tudo isso que eu falei agora em inglês, se tiver alguém de fora assistindo. So, hello everyone, thanks for your presence. Today, my name is Renato Cordeiro. I am one of the Code Lab founders and teacher of the course MAC 0475, Laboratory of Complex Systems at IME USP. I'm here with my colleagues and also teachers João Daniel and Tatiane Rosa, as well as our advisor, Professor Alfredo Goldman. Today, we have the great pleasure of receiving for our session of keynote talks about microservices, Jonas Bonér. If you want to submit questions for Jonas, please send them in the link available in the YouTube chat. So, Jonas.
Thank you. You hear me still?
Yes.
Cool. So yeah, thanks a lot for the invitation. It's a pleasure to be here, and hopefully you will learn some of the stuff that I've been struggling with the last, probably 12 to 10 years or something. It's the topic of the call today is reactive microservices, or it could equally have been probably event-driven microservices. But I picked the title Reactive Microsystems because that's the title of the book that I know many of you probably have seen. So, but reactive architecture, of course, in many ways overlaps with event-driven architecture. It's like async, it's loosely coupled, and all of these things. But I won't get into the actual details about how they relate and how they overlap and etc. Right? But more, I will try to focus more about microservices and the way I think it's the most sensible way to build microservices if you're interested in building systems at scale and are resilient. There are many reasons why you want to build microservices, and not all of them, of course, relates to that. But that has that, the sort of lens that I'm looking through things in this presentation is through the lens of maximizing, cloud type of architectures, multi-core, multi-VMs, and etc. And really building available and scalable real-time type of systems. It's probably an understatement almost to say that microservices are hyped, and it is really for good reasons. It can really help you scale the organization, scale the development teams. I mean, building functionality faster, time to market, and in having autonomous teams that help building services and shipping independently of each other, so they're not sort of standing in each other's way, and we have this really strong coupling between features that are being rolled out like we've seen in the past. So for many, that's the primary reason why you want to move to microservices. But as I said, the perspective I'm taking is that we actually, a microservices-based system implies a distributed system, and when you have a distributed system, most of the things that you learned in the past actually won't work that well. It's a very different world, and it also has lots of different more opportunities. So I think it would be a shame to move to the cloud, move to microservices, and not taking the opportunity to take full advantage of the cloud. And in order to be able to take full advantage of the cloud, and all the sort of pay-as-you-go type of architectures, is that you are able to build loosely coupled systems. And I think, and as we will see, event-driven type of architectures and thinking in events and commands can really help with that. So many when they move to microservices, probably not so much now. This is actually a talk that I gave about four years ago. And then it was at least the case that many tried to move to microservices using old habits, old ways of thinking, and often coming from the monolith. And it's often not that, successful. Many companies that I've helped in the past have ended up with something like this, that I sort of a little bit funny call like microliths, just like halfway in between a monolith and microservices, where you still have blocking RPC calls between, you still have blocking access to the database, which means that these services are usually very tightly coupled. They can't really scale very well. If one service goes down, it affects the rest of the system usually. So it can take down, functionality across the whole system and things like this. So it's really not the ideal way to move to the cloud, in my opinion, because it's hard to make scalable and resilient. It's hard to really make use of what the cloud can give us, so to speak. It's not resilient. It's not scalable, really. Instead, I think thinking in terms of events, and we will explore what that means in this talk in more depth. But thinking in terms of event-driven architecture can really help us here. And Gartner, they have been writing a ton of this, of course. And one quote that stood out for me is that event-driven architecture is a design paradigm in which software components execute in response to receiving one or more event notifications. We'll dive into what that means in a second. But one of the key things is that it really introduced this decoupling of services and allows you to build autonomous microservices. They can sort of live on by themselves and choose to accept the events that are useful for them. And once they're done, they can choose to emit events that could be useful for others, so to speak. It must through a drastic simplification, but that's sort of the way I look at it. But let's first, take a step back and look at things from a little bit more theoretical or conceptual place. So first, what is an event? An event is sort of represent a fact of information. And facts are immutable. You simply can't change something that's already happened. You can't change the past, so to speak, even though we often wish we could. So that's sort of was inherently in the way I think we should look at facts. That they are immutable. You can't possibly change them. Facts accrue, meaning that knowledge grows. As you learn more things, you can actually sort of invalidate and disregard other types of facts, but it's very important that facts sort of can't be deleted. They can't be retracted once you have accepted them, even though, of course, GDPR and many other laws sometimes forces us developers to delete facts or make them unavailable or something, using encryption, throwing away the key or something like that. But the conceptual framework that I have is that events can be disregarded and ignored. You can choose to not act on an event. What if the sender lies, for example, or if you have conflicting facts, you can choose to not accept an event or act upon an event. But once you have accepted an event, it simply can't be retracted. It can't be deleted. And it's only actually new facts that arrive that can invalidate existing facts as information and knowledge grows. Okay. So when it comes to event-driven services, we first then can choose to receive and react to facts that are coming our way, or choose not to, of course. Then we can publish new facts then as events, or actually often just put inside an event and sent out. And the interesting thing is that the way to look at the word like this is sort of inverts the control flow to regular or more classic type of command and control, that I'm sending you a command and you have to react to that. That also has its place, since often most event-driven architectures are paired with commands. But the pure way that looking at events only is that they allow you for a more loosely coupled inversion of this command and control, where events can choose to subscribe to whatever they like. They can choose to ignore events that come their way, and they are in charge of, their own destiny, so to speak. And that really helps with autonomy. And autonomy is sort of one of the key traits when it comes to, of course, availability, scalability, and all of these things. It's also very important to understand that microservices come in systems. There's really no such thing as one microservice. Sometimes they might be, but the most useful ways of looking at microservices that you split up your functionality into many quite small microservices that does one job really, really well, and that's all they do. They're a well-defined protocol for one thing, and that's all they do, more or less. And that means that they need to collaborate in order to do, more complex things and more sort of largely useful things. Here, the event stream, as I like to call it, can be extremely useful. The stream of events that are like emitted by one microservice, because that can really be used as sort of the integration point, the integration fabric for others, for other event-driven services. So let me try to illustrate here. Let's say that you have one user, and he does a request that's often in the shape of a command coming from for a physical user, so a real human, or might be an IoT device or something like that. Often through our like REST or HTTP, gRPC or something like that. It ends up in the sort of mailbox or like in the queue of this event-driven service. Some sort of work is done, and as a result of that can be captured as a fact. I've already done something here. I capture that as a fact of something that has happened, and then I emit that event out to my event stream. That means that other services now can subscribe to that event stream and act upon what the initial service was doing. And this might be, either other services, but can also be databases, external systems. It can be, other types of streaming solutions, big data, Hadoop, whatever. It's like there are many parties that could be sort of benefit from subscribing to these events. However, it's really important to also understand that they sort of what ties all these together is really eventually consistent. So events should, in my opinion, be emitted in an asynchronous fashion. That's where you get all the benefit from scalability and availability and so on. That means it will take a little bit of time for that event to propagate to the event stream and eventually over to the other services. So something to take into account, and there are of course ways of working around that and working with it more or less. But it's sort of part of this this type of architecture, and it's a fact that no one really wants eventual consistency. It's not cool, it's not hyped, even though sometimes it's sort of a necessary evil. I think it's what you have to do in order to get what you sort of the outcomes that you want. It's if you're going to like take a little step back, we all know that information travels at the speed of light. There's a hard cap of the speed of information. That means that information has latency, and this is sort of very much a reality today. That information is always from the past. We're always sort of observing something that's already happened, facts that arrive our way, so to speak. So we're always looking into the past, into the eye of the beholder. And that means also that even though like some will be philosophical, it's actually very much a practical thing, that the present for each service is relative. Other services might actually sort of experience a slightly different reality, because they perhaps see that they are not up to date with the recent changes somewhere else, or they might be ahead. So the system is always in a constant motion, in a way, to always try to catch up with the latest status globally, if that makes sense. So that's the way I'm looking at it, and there are of course ways of getting around this. I don't want that. I'm going to add a sort of database down here. I'm going to put everything, and it's going to be strongly consistent. Sure, but you have to pay the price in terms of availability and scalability by doing so. Or you can say, oh, I want to introduce distributed transactions or XA or two-phase commit or something. Sure, we can do that, like Paxos or something, but that also has a very high cost in terms of availability and scale. And so in order to really benefit mostly of the cloud, I think we have to sort of embrace the fact the present is relative, from the perspective of each service. And sort of a little bit even more philosophically, the way I look at this is as soon as we sort of exit this safe boundary of the service where everything feels like fully consistent, we sort of enter this wild ocean of non-determinism. That's the world of distributed systems. And it might sound extremely scary, but it's actually it is the reality where systems fail in the most spectacular ways and intricate ways, and post-mortems can take days to understand. It is the world where information gets lost and garbled, and we're like failure detection, understanding if your peer is down is sort of really black science, almost like it's like sort of a guessing game. But it's also this world of distributed systems is also what gives us solutions for resilience, elasticity, isolation, and recovery, and all of these things that we want as well. So I think it's worth stepping outside of that safe box of everything needs to be strong and consistent. Everyone needs to always agree upon something, and be a little bit more loose and play sort of just go with the flow in a little bit. And I think event-driven architecture can really help with this. In order to really model uncertainty, we need to model this sort of space in between the services. And as Pat Helen says in this great paper, Life Beyond Distributed Transaction, and I quote, in a system which cannot count on distributed transaction, for the reasons that I've said, the management of uncertainty must be implemented in the business logic. The business logic in the service, but also even more, I think, well defined in the protocols, how the different services speak to each other. In the case of event-driven architecture, is really about the events and commands and what they represent and what kind of semantics they have. So it's really that we need to lean into reality and exploit reality to our advantage in a way, because I really believe that events can, if used correctly, lead to greater certainty. And because the events sort of helps to craft these sort of autonomous islands of of determinism and strong consistency, that we always can know for sure that within this boundary we are safe. When the event arrives, there won't be any race conditions. There won't be any garbled information, or it's like it can be fully deterministic within my service. And so we can live happily under the illusion that the time is absolute and there's a single present, even though there's not, as I talked about, and that the world is truly deterministic, because we can perceive it as such from within that little island. And in order to do so, I really believe that mutable state needs to be contained and made non-observable outside this boundary. It can only be used for local computations. And the interesting thing is, like, what do you do then? I mean, when you're sort of done with that local computation, then you wrap it up as a fact, as a stable value that others can depend their reasoning upon, and then you publish that out to the world. Immutable facts, sort of packaged up as events. So then you get the best of both worlds. You get the sort of deterministic world within the service where you can just continue working with mutable state and everything that will allow. But if we have a service, a well-defined contract and how we publish facts to the outside world, and also how we act upon facts that come our way, then we can sort of others can rely on the outcomes of our local computations and still rely on these values. They won't just change. They're stable and they represent something that we know for sure has happened in the past, just as facts should. Okay. And this philosophy, in my opinion, ties very much into domain-driven design. I think about domain-driven design and what many people started calling events-first domain-driven design. It's really a great tool because it lets us focus on domain objects and focusing on instead of like focusing on structure too early in the design process. Okay, as Greg Young said, that when you start modeling events, it forces you to think about the behavior of the system as opposed to thinking about the structure of the system. And so some guidelines here in how to think about these things, that we should not start focusing on the things. You know, when I took object-oriented class back in the day, that's what I was taught. I should focus on the things. I should go out and find the nuns. You know, they could be great candidates for objects and classes and these things. But instead of doing that now, I think we should instead focus on what happens. We should go out and try to find the verbs instead of the nouns. And these verbs then can become our events. And we should really work as detectives. Try to mine all the facts. Try to find what are the facts that flowing around in the system, and what are the facts that others rely upon, etc. And even more, of course, perhaps causality of facts. You know, one fact can lead to the next, to the next, to the next. And one great tool to get that done is what has been popularized with a sort of activity of event storming. Event storming, you should just look into it some more, but it's a really good tool in which essentially we bring in all the stakeholders, meaning the domain experts, the programmers, into one single room and have them brainstorm, essentially, trying to find the domain language through the events and understand how data flows from one function to another, or one service to another, and how they function or sort of flow between subsystems or external systems and so on. And really trying to understand what are these verbs. And how are they sort of causally related to each other? Because that's really understanding how the system works. So in an event-driven design, what we should try to do is we should try to focus on finding first the intents, meaning communication, conversations, expectations, trying to understand contracts and control transfer. All of these things are about intents, which is extremely important, but also facts. And facts are usually found around state, history, causality, notifications, state transfer, and things like that. And intents are usually represented, or best represented, as commands. You know, this is classic, more command and control. I'm telling you to do something. When the user sends me a request to start doing something. While facts is a great sort of candidate to be modeled as events, if that makes sense. So if we should try to understand commands and events a little bit better. So commands is sort of the object form of a method, you know, over some sort of action request. They're usually phrased in the imperative, meaning create order or ship product. I'm telling you to do something. And that leads to reactions. You know, some reactions is some sort of side effect triggered by acting upon this. Create order, yeah, I might go off and then create the order, actually doing that. And that leads to, that action, sort of side effect, can be then captured as an event through the fact that I did something. And so events represent something that has already happened. And they're always, or at least usually, phrased in past tense, order created, and the order has been created. So that's why I'll sort of pull commands and events and side effects together. So if I try to wrap up a little bit, commands is really all about intent, while events are really intentless. Commands are fully directed. You know, I'm telling I'm telling service A to go and do something. Events are anonymous. I don't care who actually submitted the event. I just act upon it. It arrived. I subscribe to it, and I receive it, and I just act upon it. So commands, they have a single addressable destination, while events are like 0 to n. You know, they just happens for others to observe. It can be 0 if there are no subscribers. It can be 200, 1,000. It really doesn't matter. You know, And so it's clear that commands, they sort of model personal communication, one-by-one communication, while events sort of model more broadcast type of information. And it's also clear then that commands, they have sort of a distributed focus because it actually might cross address spaces if I'm telling someone somewhere else to do something, while events are really just local, at least from the perspective of the service receiving it. It just ends up in his mailbox. There's really nothing about distribution. It just emits them locally. Then they might be relayed, in a distributed fashion. But conceptually, I think about them as distributed and local. So really, and as I said, commands really sort of captures command and control, while events really captures full autonomy. And where I only choose to act upon what I like to act upon, where I can never be told anything, unless I accept the command, of course. But this really gives us these sort of event-driven, really loosely coupled services. They can be moved around and not really strongly coupled in any way. So we can really help. So DDD can really help us using events to define bounded context. I don't know if you know bounded context from DDD, but that helps us define well-defined protocols, essentially establishing the promises that I make to the outside world, the promises that I choose to keep, and what happens if I don't keep them. If I fail to keep a promise to the outside world, what happens? It's really sort of inverse the control and puts the service in control, in charge of its own destiny, as I said. So that's sort of some of the ways I'm looking at it from a design perspective. And the question is then, if we are able to model communication and coordination and integration and all of these things using events, are we done now? Is that all events are useful for? I mean, perhaps, it depends on what you need, but I think it really has made us come a long way. But I personally think that just scratches the surface of events, because events can be used for so much more. For example, persistence, and having a really solid notion about time. There are many other things, that we can talk about that events can help with as well. But in the interest of time, I'm just going to focus on these two in this presentation. So let's talk about event-based persistence, what that means and why it's useful. Most people are used to update in place. That's sort of classic CRUD: create, read, update, delete. So update and delete means that you actually overwrite existing values. That's the update in place. And all the way back to 1981, you can find this Jim Gray quote. Jim Gray is actually one of the persons that have done most work, foundational work for database systems and transactional systems specifically. But he already in 1981 said that update in place strikes system designers as a cardinal sin. It violates traditional accounting practices that have been observed for hundreds of years. And yet again, I think we should look at how are we solving things in the real world, and then learn from that in how we build systems. So in this case, relearn basic accounting principles. And how have we actually done accounting? Decades, or actually sort of centuries back. And we have a lot of unlearning to do. And so because the way I look at it, that event logging, and I'll get to what that means, can really become sort of the bedrock for how we look at consistency, how we look at persistence and all of those things. And event logging is really about storing each event as it arrives to the service in order as they arrive down on disk. So you get this journal of everything that happened in the system, or actually everything that's sort of been emitted out from the service. We already talked about that each service does something. It represents that action in an event. Now that doesn't only have to push it out through this event stream that we talked about, but can actually log it durably on disk. And then that becomes sort of a bulletproof record, a journal of what everything that happened in that service, at least anything that did something worth keeping, everything that ended up with a fact of some sort of change. So it can really become our ledger in a way. I mean, just like transactions in a ledger, and it's not surprising that like all classic database systems, relation database systems, Oracle, Postgres, or whatever, actually have the concept of a transaction log, where all transactions will end up in order in a journal. And event logging is similar in a way. It's just a sort of a journal about also history of everything that happened in the service. And if we have this event logging journal, that can really be the foundation for consistency, for availability, for scalability, and for traceability. All quite good things, right? As Pat Helen said in this great paper, Immutability Changes Everything, the truth is in the log, and that the database is a cache of a subset of the log. So the question is, why should we use a subset of the real thing when we can use the real thing directly? One of the reasons is of course that historically update in place was needed because disk space was really expensive. So you actually had to overwrite because you simply couldn't keep everything on disk. But that's not the case today. We're still stuck with the old so classic architecture designed for a problem that we really don't have today. Today, the disk space is really, really cheap. So there's really no reason to not store everything that we have forever, at least as long as we might need it, And so it's really, the log is really, in a way, sort of at least the foundation of a database of the past, not just the present. It can provide more answers than just what is the value right now. And if I want to know, if I were using a traditional SQL database, then I would have to do that historic sort of logging in yet another table manually, right? To go back and check my orders, for example, or something like that. But if you use event logging or event journaling or whatever you want to call it, it's already there. You just log the events as they are emitted, and that's it. That's your bulletproof journal. And this is a pattern that often called event sourcing. I think event sourcing can really be the secure for this cardinal sin. It's sort of a pattern that abstracts over this event log, in which you log every state change to component in the order they are created. And to dive in a little bit what it means. It means that for the happy path, when everything is going as planned, we essentially receive and verify the command, for example, approve payment. We create the payment, we approve the payment, and out of that we create the event representing the fact that the payment has been approved. Then we append that to the event log, and we update the internal component state when we know that we have safely logged it. So there's really no way of we can losing that event. And then we run the actual side effects when we update the payment. However, in the sad path, then we can use this event log now to recover from failure. The only thing we need to do now is rehydrate the events from the event log. That's running them, replaying them in the order they all arrive, bringing the internal state of the component up to speed. And this is what I often call memory image. And if you Google that, and Martin Fowler has a really good sort of article where he goes into more depth about that, as well as one on event sourcing, if you want to read about that. Some of the benefits of using this somehow alien or a little bit different architecture compared to just using sort of more classic CRUD and update in place, is that we have one single source of truth with all history for that component, everything that ever happened. Okay, we have so it really allows for a memory image, and what the memory image does, I didn't go into detail about that, is that it allows durable, fully persisted in memory state. That means that this service can now serve sort of reads directly from memory, super fast in real time, while it writes, or makes it all the way down to the event log. So it sort of decouples the performance and sort of latency and throughput sort of capability from the read and write side, so to speak. And so because it can always give answers safely directly from memory. And it's actually beyond caching, because in caching you have all these problems of keeping the cache in sync. Here with event sourcing, the truth is in the log, and the services just happen to have a fully safe sort of mirror of that log of the latest value, essentially the folding of the whole log into the latest value. If you want to talk about, if you look at it from the functional program perspective, from practical standpoint, it really helps avoiding this infamous object relational impedance mismatch, where you have your tables and you have to map them to some sort of records or properties or variables up in your code. And that's is the reason why we had to do Hibernate and JPA and many other OR mappers, and they're really a pain, and they're sometimes are suboptimal, and they're usually very inefficient. This just removes that problem. There's nothing to map, because you can have the ultimate representation in your object inside your service, however you would like to represent it, and you have the ultimate representation on disk. In especially modern SSD types of architectures, they thrive from having a single writer writing just down extremely fast consecutively in an event log. So you get the best of both worlds in a way, which can give really high write throughput and extremely, of course, fast read throughput, since it just serves from memory. And it also sort of ties into, sort of unifies the idea with the event journal and the event stream, as I talked about, because you can actually use that event journal as the event stream, and in which others can just subscribe to whatever happens in the order as the events are emitted. And as I said, a really good mechanical sympathy, single writer principle, and all of these things. Another cool thing is actually, that one of the harder things in distributed system is to have a strong, stable notion of time, and causality. Causality is extremely important. It's usually, the strongest guarantee that we actually need in many cases. We often don't need ACID or linearizability, if that many work with in distributed, sort of the hallmark of consistency in distributed system. But causality is often good enough. It's how we humans experience the real world. In the real world, it's all causality. It's in the eye of the beholder. It's all eventually consistent, but it's still causally related. So being able to map and model the causality is what gives us read your rights type of semantics, and often it's good enough while still allowing for headroom for scale and things like that. So a really strong notion of time is important. And as Greg Young said in this presentation I quoted earlier, is that modeling events forces you to have a temporal focus on what's going on in the system, where time becomes sort of a crucial factor in the system. It really becomes first class. And event sourcing really gives us a great way to model time, where event is sort of a snapshot in time, where the event ID can be our index in time, where event log is our full history, everything that's always happened, and where a database is now a database, not just everything. It's not just the past, actually, but the past all the way up to the present. Which is like way beyond what most databases gives you, because they just give you a snapshot of now, in a way. And another sort of interesting thing is that event sourcing, of course, allows you for like time travel in a way, where you can sort of replay the log for historic debugging, understanding So going back in time and slowly replay it to understand really what went on. How did we end up in this erroneous state? Okay, we can replay it for auditing. We have a bulletproof audit log without having to do any extra work. The log becomes the audit log by itself. So we must have full traceability of everything that ever happened in the system. We can always, of course, replay on failure, as I talked about. We can also replay the log for replication. If we want to spin up more instances across the cluster, we can simply just replay it. And once they are spun up, they can simply consume the event log of the master, so to speak, to always be in heart, and really always be up to date. And all this, in a completely async, loosely coupled fashion, which is quite interesting. I just added this slide because actually I just love this movie. We can even actually I actually work with clients that have benefited from being able to fork the past actually, and having sort of two distinct paths in which you sort of roll over the system and letting the old sort of branch to die off, and having the load balancer start gradually sort of send over requests to the new branch for many different reasons, for upgrade reasons or whatever. So all I just want to say is that it gives us a ton of options to be able to have the event log for a stable notion of time and through the event log, and I mean to have an easier way to reason about causality and actually how things asynchronously just evolves in the system. So the key takeaways is that I don't think you should be good. Think that you sort of settle for building microliths, sort of the half step in between monolith and microservice. Why don't you go all in, even if you can sort of benefit from the faster time to market and having these autonomous teams working. That's all great, but many, especially if you want to move to the cloud, will be capped then by that design in terms of taking full advantage of the cloud. So I think it's better to think about them as truly distributed systems, and that microservices really come in systems. There's really no such thing as a single microservice, and that's all it is. You need to think about them as systems that evolve and communicate with this sort of ideally autonomous services that can come and go, and it just forms and collaborate and sort of force or clusters and collaborate, as the system evolves. And I really believe that reactive and especially event-driven sort of domain-driven design can really help us there. Thinking in terms of events, thinking in terms of commands, and not just thinking about it from a communication perspective, because that's all fine. But if you always need to sort of, once you're done with the events and commands, in terms of communication, when the services is sort of done with this calculation and want to persist, if you always have to go down to a database then and use sort of update in place, destructive updates, then you start, in my opinion, lose half of the story. You already have an amazing architecture going. The events are already fly around, and sort of end up in your service naturally in the order they are consumed. So why don't you just log that and get this really bulletproof journal, and can start building on top of that in terms of really scalable and available event persistence, stable notion for time, etc. Right. So I wrote some more about this in my book. This is just a very small mini book. It's not even worth calling the book, honestly. But I think they did that orally. Anyway, it's really small. It's actually you can download it for free at this bit.ly link if you want to read more and get into a little bit more depth. So that's all I had. Questions? Or?
Thank you, Jonas. Awesome lecture, and we are very happy to say that we use your book in our course. So
I'm really happy to hear that. Hopefully it's useful. since you invited me here, I assume that it was somehow useful.
Yes, surely. So we have a couple questions here. I personally submitted some questions for voting. I'm glad that they received many votes, so I can ask them. So the first question, which was made by me, it's what are the trade-offs of using a broker such as Kafka or Nets, among the popular options, as an event store? Do you consider you should use another database as your event store? And if so, which one? What have you seen?
Yeah, so it's there. There are some, and of course, disadvantages with everything. It's not just event sourcing is not a silver bullet, for example, and event-driven architecture is not either. But if we talk about the durability of it now and the brokerness, some of the things that are hard is, of course, for newcomers if they're not used to this way of looking at the world or this way to think about things. It's a quite unfamiliar model even if you get that you actually can communicate with events and commands and how all that works, this whole persistence thing can be quite unusual. So there is an educational sort of practice, or actually challenge, I rather say, that in order to train the teams and to probably do some POCs and get familiar with the model. And another thing that I think is also challenging is versioning, of course, and how you do upgrades of events, and how you think about I'm sort of upgrading in general. That's sort of a quite big topic by itself. Sort of one of the guys that I quoted in this presentation, Greg Young, he's one of them, the people that have advocated for event sourcing and the sort of sister pattern, you may say, CQRS. I didn't have time to go into that here, but it actually solves, the read side in a more efficient way. He actually wrote a whole book of versioning with events. So I encourage you to check that out. It's a quite involved topic. We have some tools for it in Akka, and there are good patterns. I don't know if I have time to go through that now, but but saying that's one thing to think about in advance. Probably how should we do upgrades? How should we do versioning? Build versioning into your eventing from day one. And another one I sort of touched upon that is that even though I think it's sort of conceptually wrong to delete events, it's sometimes needed. For legal reasons or for moral reasons or whatever. And how would you then do that? There are many different ways you can do it. You could, of course, go in and physically delete them. Delete the data, or you can use extremely strong encryption. AES-256 or something, and then simply throw away the key, destroy the key once you're done, or once the user flags that he wants or she wants that to be done. So that's just a few of the challenges that comes with event sourcing. But in my experience, when you get over this unfamiliarity of the model, when you actually think through how you should do version and deletion from the get-go, I think it has so much more to offer, and I really think it's worth it. Probably not for all services, that I have to say. That it's not a silver bullet and says that you should event sourcing for everything. That's not how our customers are using it. Sometimes CRUD is absolutely the best job for the sort of tool for the job. If so, use it, of course. But for a lot of these high scale, low latency, high throughput, sort of more real time type of systems, then removing bottlenecks and having a really high ceiling in terms of scale and availability is important. And then I feel like event sourcing and event logging, and regardless if you use Kafka or Kinesis or some homegrown, whatever it is, Pulsar is many using nowadays. It's like I think it's worth it. So I just encourage you to learn about it, fool around with it, and see it as yet another tool in the toolbox to be used when appropriate. So try to be a bit, less hyped, bit more pragmatic, and see through the hype in everything. I'm sort of presenting this as a silver bullet, perhaps because I'm excited about it and want to get everyone excited, but it's definitely not. Microservices is not either. We're like, we're sort of reinventing ourselves as an industry every 20 years, and now we're done full circle again. It's like now we're even back to functional programming, but now in a distributed fashion. So that's actually slowly many architectures now becoming more entities, which means they are objects again, and we yeah, I can talk a lot about that, but it all comes in circles. Slightly better every time around, which is good.
Awesome. Thanks for your answer. The second question I have here, it's people usually talk about event-driven for backend services, but how about the front end? How to embrace this reactivity approach with HTTP connections, or do you think about other options when trying to make this connection from back to front?
No, I think there's absolutely some a lot to learn. I think that we as backend developers actually has a lot to learn when it comes to event-driven architectures from the front end. There's been more natural. I remember when I started building UIs about 20 years ago. I remember I used this library called Qt. It's a C++ library. I don't know if some of you might remember it. That was how the Linux KDE window manager system was built and stuff like that. But they had this concept of signals and slots, which was essentially a fully event-driven architecture about 20 years ago in C++ then, and of course they didn't invent that either. I'm just bringing up this one as an example of that. They've been ahead of the game when it comes to that for a long time. Swing, of course, and in Java had it, and and there are many modern shapes or forms of that. I think that so for example, React has a really interesting library called Redux that's essentially is event sourcing, where they have this notion of stable facts in an event log, and we've been toying a little bit with Akka and specifically Akka serverless, which is our serverless offering for Akka, in how to bridge the gap of eventing down in the backend system all the way up to eventing in the UX. Specifically, we looked into using React and Redux, for that. But there are, of course, many other libraries or frameworks that are providing the same thing. But I think we have more to learn when it comes to this architecture, at least in my opinion. Web developers, or especially UX developers, think more naturally probably in events.
Awesome. We have a question here from Vander. How do you think adopting reactive programming improves the implementation of reactive systems?
Okay, so I don't know exactly what's the intent of this question, because the way I look at it is I see reactive programming and reactive systems as slightly different things, and that I wrote a whole 20-page article on that, so I won't reiterate that here, of course. But in summary, I see that reactive programming is sort of a subset of reactive systems. Reactive systems really take reactive programming, async, being able to run things well in multi-core. We know they have the futures promises, coroutines, fibers. There are many different, but they're all local, and local abstractions is great if you only want to run on one machine and want to leverage all the cores on that machine. But they don't solve the problem of scalability beyond the single machine. It doesn't solve the availability problem, because if you have one machine, then you by definition have a single point of failure. If that machine goes down, what do? You're screwed. So in that sense, you need something that adds the notion of distribution. And I think that's what reactive systems do well. They add the notion of distribution, of location transparency, of mobility, of autonomy, true autonomy with the services that can move around. And then you need a distributed system for that. And I think reactive systems can really help with that. So I think they're slightly different ways, but I would say reactive system is sort of superset of reactive programming, and they're both extremely helpful, extremely useful, but for slightly different things, I think. In Akka, for example, we of course do both. We have great abstractions for reactive programming in terms of futures, and of course actors work extremely well in the local setting. But you also have the notion of taking message passing in this case and turning it into distributed through stable addressing and through sort of the separation of the address and the instance. So the instance can move around and you still can work with the stable address. And that has helped us a lot. So I think both matters. So I don't know if that answered the question or if that was even the intent of the question, but that's how I look at reactive programming versus reactive system. There's really no versus, really. It's more like more tools in the toolbox, use what's useful to solve your problem.
Yes. Well, when there is our student, and we know that he read your article, so probably he wanted to listen your opinion about the subject personally with this opportunity.
Cool.
Well, Jonas, I think this is about the time that we had planned. So thanks a lot for your time, your presentation, and your answers. We have a couple questions here that remained. Would you be okay if we sent you these questions so you can take a look and maybe
sure.
answer them?
No problem. Absolutely, no problem. I'm happy to.
And well, so I will just thank everybody here in the audience watching via YouTube, and thanks for the opportunity to explain about all those concepts for our students and for all other people watching here in Brazil. And I will just give a bye-bye in Portuguese too, and then we can close our lecture today.
Oh, before it, I want to send an event. Jonas, thank you. It's a broadcast.
Thank you. Thank you. Yeah, I'm really happy to be here, to be invited. I mean, it was fun. As I said, I haven't spoken about microservices for a while, so it was fun. It's also fun reiterating some of my ideas here. So thanks. Probably thanks to COVID or due to COVID. It's like no, I haven't spoken about anything for about 2 years. So it was really fun to get the opportunity.
Yes, and we hope one day having the opportunity to receive you in Brazil personally when things get a little bit better.
Thanks a lot. I love that. I've never been to Brazil, so that's definitely on my list.
Awesome. E, bom, obrigado, pessoal, todo mundo por ter assistido hoje. Não se esqueçam que a gente está na nossa série de palestras aqui sobre microserviços. Na quinta-feira, às 16, a gente vai receber Michael Gears para falar sobre microfrontends. Então, não percam a oportunidade de assistir e muito obrigado para todo mundo.
Thank you again. It was really great. Thank you, Jonas.
Thank you. Appreciate it. Thanks. Bye.